Here are the Mod 15 Part 2 notes. This is page 2. So pages 2 and 3 are going to walk through an example, give you kind of the chance to dissect what we're doing, make sure it makes sense, and then the last couple of pages has example upon example. So here's example 1. We got the proportion of patients who visit the emergency room and die within a year, well, morbid, is 0.06. Okay, so notice this is our proportion, 6%. We use it in Excel, we use it in our formulas as a decimal. Suppose a hospital administrator is concerned that his ER has a higher proportion. In a random sample of 250 patients who visited the ER a year ago, he finds that 20 have died. We want to conduct a test at the 5% level of significance, so our alpha is 0.05, using the p-value approach. So this does get a little overwhelming to start. There is a lot going on here, so we are going to walk through this. First, this thing is we are talking about a proportion. So our research question is going to have the same format. So we want to know if the proportion of emergency room patients that die within a year, we want to know if that proportion is higher than the population proportion of 0.06 at the alpha equals 5% level of significance. First thing we're going to do is set up our hypotheses. So let's take a look at the information that we have. Here's our population proportion. So that's what we're comparing to. We want to know if his ER has a higher proportion. So that gives us enough information to set up our hypotheses. Our null hypothesis is always status quo. That the proportion is 0.06. Our alternate, because we want to know if we have a higher proportion, has got to be that our proportion is actually higher than 0.06. And now, we are using a p-value approach, so our decision rule, we are going to reject H naught. We're going to reject our null hypothesis if our p-value is less than alpha. So in this case, if our p-value is less than that 0.05. So think about what that means. I have got a population proportion of 0.06. I am checking to see if the sample proportion is higher than that 0.06. So it's a right tail test, which means my alpha equals 0.05 here. I want the cutoff that leaves 0.95 to the left. Okay. So our question is, where does that 0.808 lie? Right, is it to the left of that cutoff for my alpha equals 0.05, or is it to the right? And I realize that right now you're wondering where I got that 0.08. Let us take a look at what we've got here. So we have a random sample of 250. And in that, we have 20 that have died. So my sample proportion is that 20 over 250, which is where I got the 0.08. So I apologize for going out of order. Okay, now, before I move any further, before I move on, we do want to check for normality. So we're going to, and we'll put this in hot pink, check our central limit theorem. This is our check for normality. N times P times 1 minus P has to be greater than 10. Here our sample is 250. My P is the population proportion, 0.06. 1 minus P is 0.94. When I multiply those together, I get 14.1, which is greater than 10, which you need to acknowledge, so we are okay. I need my standard deviation for my sample proportion. So here, I got the square root of, let's see, I got 0.06. We always use the population parameters when we have it over n, 250. And I get 0.0150. Now, I have my p hat, I have my p, I have my standard deviation. All I need to do now is go to Excel and compute the probability that this sample has a proportion of 8% or higher. Okay, now, right hand is what we're looking for here. We're off here. So when I plug this into Excel, I've got 1 minus norm.dist using the normal distribution. We checked for normality, right? 0.08, 0.06, I did not leave enough room. Awesome. Let's see, what is my standard deviation? 0.15 and then 1. This is going to give me my p-value. Guess I could have planned better here. And I am going to highlight this in hot pink so you know this was our Excel command. I get a p-value, the probability that my proportion is greater than 0.08 of 0.0912. So we need to use that decision rule to draw my conclusion. So I get 0.0912. That is greater than 0.05. So my p-value is actually greater than my alpha. So we fail to reject H naught. We're going to state the conclusion. And I'm going to, it says use complete sentences. I'm going to kind of write this in 4 parts instead. And so here's how we're going to do this. First part, I am going to say fail to reject or do not reject H naught. there is insufficient evidence or not enough evidence at the alpha equals 0.05 level of significance. And now I need to state it in the context of the problem. To suggest that the proportion of deaths at this ER is higher than the national average and we're going to state that of 0.06. My poor planning there. So we are going to go on to page 3. So there's that. Hit pause if you need to write something down. Page 3 explains what we just went through. So we compared a calculated sample proportion. Our sample proportion was 0.08 with a hypothesized population proportion. Hypothesized because that was the proportion that was stated. And so what we're trying to decide is if the difference between these two is random variation, so normal, or systematic variation. You can read through this next part. It just types out everything we just did on page 2. And so when it comes down here, we failed to reject the null hypothesis. We did not reject H naught. This is due to random variation. So this is what we found. Pink is a bit brutal. So read that, make sense of it, so you understand the gist of our hypothesis testing.